Good afternoon all. Oh, how the TS100 soldering iron has changed my life, but probably not in the way you're thinking. You see, I'm now having to think about power sources. Now the 13.5 volts, which can be as low as sort of 12.5 in the evening, or it could be 14.4, often isn't enough for this thing. You can make it work on sort of around 12 volts, but you have to set this to a very high temperature because you need to fill the tip, particularly if you're soldering stuff like this, big pieces of metal. These are banana plug ends. You have to fill the tip with energy, joules. Then when you touch that onto there, the heat gets sucked out by the cold piece of metal, so you lose those joules. You then want to put them back. Now that means you need a certain number of watts in the form of heat output from the element, and that's what I'm lacking at 12 volts or 13 volts. I'm lacking watts to keep this tip hot. So how do I get more watts? Well, this is just a resistor. The element's just a fixed resistance, effectively. I need more volts. And one suggestion that several people had, including Mike Harrison, Mike's Electric Stuff, power tool batteries. So I've got these Ryobi power tool batteries. This one is nickel cadmium. That's old. I probably wouldn't use that. I've got a first generation 18 volt lithium here that doesn't have the battery voltage monitor thing. And then I've got these lithium plus. This one is a 2.5 amp hour, so that is 45 watt hours, and this one is a 4 amp hour, so that is 72 watt hours. Now the difficulty here is, how do I connect this? This is this rather nice cable I found with a 2.5 one end and a 2.1 the other. The 2.5 goes into the soldering iron. How do I connect that 2.1 to that? And there are various options. One is to take something like this and drill a hole in it somewhere and fit a 2.1 millimeter power jack. This is a very interesting socket. We'll come back to that. But this is very bulky, this torch. I mean, it works. It's got a 18 volt incandescent lamp, but yeah, like I say, it's just very big. I don't really want to be having to use something this big just to connect my soldering iron to a battery. But I've also got this. This is quite old Ryobi, 2009. It's the BFG something or other, and it's actually a battery sort of state of charge indicator. Now this came out sort of around the time that the NICADs were out. It does work on the lithiums, sort of. You plug it on there and it's got 4 LEDs, red, yellow, green, and another green. So that's saying this is sort of 3/4 charged. But I mean, this thing's actually a bit of a pain because it does this lamp test first. So it actually takes probably about 5 seconds before it actually gives you the result. And whether or not that ties up with this one's built-in meter, that's saying 3 out of 4 bars. Yeah, well, it does seem to tie up at the moment. But of course, this thing's not very useful now, certainly with the lithiums, because they have their own built-in voltage indicator. You just press the button and it shows you how full it is. Now I should probably use that torch because the connectors in there are just 2 connectors. Let's illuminate them, one side and one the other, and they simply attach to positive and negative on either side of this sort of turret. This one actually has 3 connections. It's got that 3rd connector there, which connects to this 3rd plate on the battery turret. But what does that do? Now on the old nickel cadmium batteries, there's no intelligence in here. It's just, I think, 15 cells, 1.2 volts each, all in series. That 3rd connection, I think probably, and I'll have to take this battery apart to confirm it, it's a temperature sensor to detect whether the battery is going over temperature, and it could signal to the charger everything's getting a bit hot, back off or switch off or do something like that. Now the thing about the new lithium batteries is that they obviously have a fair bit of intelligence, otherwise you wouldn't be able to have that battery monitor. They've got sort of overload protections, they've obviously got balancing circuits for balanced charging. So what does that actually do? Is it still just a simple temperature sensor? I don't know. And this third connection in here, that one at the back there on the flat, what does that do? And what's it do in the context of trying to measure the voltage of the battery? I don't know. So this is starting to seem a bit like a can of worms. But it's all very interesting, so I'm quite sort of keen to get to the bottom of all this. What is that third connection? What is it in the nickel cadmium? What is it in the lithium? So let's take this apart. And this is why this design of battery with this very long sticky uppy bit actually had that, because there is the 15th cell sits inside that little tower. The other 14 cells are down on the bottom. But yeah, that third connection has a blue wire on it, and that goes down there. Let's take a look at where it goes. Right, well, the blue wire goes into this two-terminal device, which is down inside here, taped to this cell and quite close to that cell. But of course, it's not measuring the temperature of all the cells, only of one. Well, that's a bit iffy, but I suppose you've got to put it somewhere. Now, this might even be a mechanical switch, which at a certain temperature, maybe bimetallic, so it just opens a couple of contacts at a certain temperature, or it might be resistive, it might be a thermistor. The black wire simply goes to a common point, which is battery negative. I'm pretty sure, yeah, it is battery negative, which also runs down to this wire here, goes to this piece of metal and goes to the negative of the first cell in the series chain, which is this one here. So yes, it is some sort of sensor, almost certainly temperature, because of the way it's been close coupled with that cell. Right, so now that we know what that third connection is, let's take a look inside here, because I had this apart earlier on, and it's a simple board with a microcontroller, 4 LEDs, the red, yellow and 2 greens, a voltage regulator there, but there are also a couple of fairly high wattage resistors. And I think what this does is it puts the resistors across the battery to just sort of load it down a little bit. They're 1k each, so in parallel you've got 500 ohms. And then with the battery just loaded a little bit, it basically measures voltage to try and get an estimate of state of charge. Let's try and attach this to there without that little spark. And it goes through its sequence. And you can see that it's saying that this NICAD is fully charged because I charged it this morning. But what does that third connection do? If I slide this along so that it disconnects from that third connection, doesn't seem to do anything. And yet that third terminal on this voltage monitor board is connected up, and I'm not entirely sure why. So that third connection is the 3 points on that sort of triangle there. And then a little tiny track runs round here, round the back of there, round here, and actually goes into the microcontroller. Now, did they connect that up because they thought, well, we might want to just check what that third connection's doing, and then actually ended up writing firmware that ignores it? Or does it use it? I don't know. And why am I even that bothered? Well, if I'm going to use this as a method for supplying power by putting a socket in this box, because actually there is a space for it, it can go there, and I can use that socket, this one here, which I'll come to in a moment because it is quite clever. What I don't really want is these 4 lights being on all the time while I'm using the soldering iron, because they don't need to be on, because I'm not going to use the NICAD. I suppose it'd be useful if they were on when I was using the NICAD. But if I'm using the lithium, of course, it's got its own battery monitor. But actually more important than those 4 LEDs are these 2 resistors, because that's burning a fair bit of power. And this unit gets quite warm if you leave it on for any length of time. And it's because those 2 resistors are just draining energy out of the battery. So what I really want to do is isolate the sort of circuitry of this from its own connectors, these springy metal things, while I'm using it to act as a little interface to power the soldering iron. Now I think I can isolate the circuitry on this board when you plug in the cable, because this socket very helpfully has a changeover switch on it, which can actually, when you plug the plug in, it can switch off the circuitry on here. It's not going to be easy because of the way that the negative battery terminal is very close to the chip, so the cutting on the tracks is going to be a little bit tricky, but I think I can do it. But I can only isolate one of these terminals, so the other one, this one that is on that temperature cutout switch, however that works, and goes into one of the microcontroller pins, that's going to still be there possibly. Right, that switch, that little temperature switch, was across ground, or 0 minus, that's the minus one there, and this third terminal. So that bleeps out with only a few ohms. So I'm now thinking it's probably a switch which opens when it gets hot, probably bimetallic. Let's just try this on the ohms range. And that's saying that it's virtually no ohms at all. So I think it's closed when it's cold and it opens when it gets hot. See, the thing that's bothering me is that the little cutoff switch on this socket is going to disconnect, because of the way this works, it's going to disconnect battery negative from the chip. So you'll still have battery positive going to the VCC on the chip. You'll also have negative going through that temperature sensor and into this other pin on the chip. What's that going to do? Well, I suppose I can check it actually, because if I hold plus and minus on like that and pull that temperature sensor tag away just to see what it does, well, it doesn't seem to do anything. Now if I leave that temperature sensor tag in place, which we know is effectively 0 volts, and pull the battery minus away, it does something really weird. The red LED stays on, so it's kind of indicating a fault condition, but I don't think 0 volts is actually going to that chip at all. I think it's just going to one of the input pins. So you've got one of these sort of phantom powering situations. I'm not sure whether this was ever intended to work like that. If I let that reattach, the microcontroller reboots. Oh, actually it doesn't fully reboot. It just does that display wind up thing. That's really weird. I don't get that. Now, I thought that most of the heat that I was feeling when this thing was in its case was from those resistors, but actually they're not that hot. They're just mildly warm. Most of the heat is coming from that voltage regulator. That's actually pretty hot. It's a 78L05, but of course it's taking, well, this can be as high as 21 volts. Well, the lithium ones can anyway. What's the NICAD's going to be? About 1.5 times 15? Well, I can't think. But anyway, that's getting pretty hot because it's having to take that high voltage down to 5 volts. So as long as disconnecting battery negative disconnects both the resistors and the regulator. Yes, that's there. And just leaves that little red light on, that's probably not too bad, because that probably doesn't draw very much current at all. Is it going to behave like that on the lithium one? I suppose I better check it out. Right, I've closed the blind so we can see these LEDs a bit better. So what I want to do is pull the battery negative off, because that's what the switch on this socket is going to be able to do. Disconnect battery negative. And on this one, that LED, the red LED, doesn't remain lit, which is interesting. So on the lithium one, it probably disconnects the circuit completely. Okay. Something really weird's happening now. If I connect that third connection onto the lithium one, it's giving a reading of just red and yellow. If I disconnect it, the 2 green lights come on. I wonder whether this was an update so that it would work with lithium batteries. I don't know. I mean, what would they have done with that terminal on the lithium batteries? Wow, that's quite hot on the back of that board. It actually feels hotter under the resistors than... Are they hot? Yeah, so this is all very confusing. I suppose really the issue is if this is connected onto here and I isolate battery negative, which is this one, which I'll do with a piece of paper, does this board cool down, and is it does the significant drain that this device puts on the battery, does that go away? So I'm just going to put a little piece of paper in under there so that battery negative is disconnected. This thing is now only connected on the remaining 2 terminals, and I'm just going to wait for it to cool down if that's what it's going to do, and see if the regulator and those resistors are hot. Now, one of the issues that I kind of predicted is if I use this socket to supply power to the soldering iron, I've got 20 volts lithium across the inner and outer pins there, and if someone pokes a screwdriver in there, you'd have tens of amps flowing and things would melt down quite badly. But in actual fact, with no plug plugged into this socket, this metal surround here is completely isolated. Now let's just check with this isolated whether either of those two components is warm, and no, they're both cold. I'll now put it on the NICAD, because on the NICAD it had that strange side effect that the red light was on its own, courtesy of that third connection. So there it is, battery negative is isolated, but that third connection seems to be lighting up the red LED for whatever reason. I'll just leave that to see if the components on there are cold or hot. Now this socket is very interesting. Let's zoom in a bit on my diagram. When you have no plug plugged into it, the chassis part, this bit with the screw thread, which actually has a nut that you can attach, is completely isolated, because this switch, when the plug is out, is in the out position and is connected to a sort of free connector. I think it's this one here. And so what I could do is I could connect the internal circuitry, the little battery voltage monitoring thing, across that connection and this connection here, so that when nothing is plugged into this socket, the battery voltage monitor carries on working as before. Now when you push a plug into here, this thing flips over to the in position. That will connect the battery to the center pin, the positive to the center pin, and the negative to this chassis outer, and be able to supply power to my soldering iron. It will also switch off the internal electronics of that voltage monitoring thing, so that won't be drawing any energy, which is what I want. And it also means that if nothing's plugged into here, this chassis metalwork here is disconnected completely, and therefore if someone sticks a screwdriver in it, you're not going to get a nasty bang. So this little socket is absolutely perfect. It isolates my two concerns. One, that someone might short that and damage well, the connections to the battery, maybe even the battery itself. That's not going to happen because of the switch. And also it's going to actually shut off the battery voltage monitor so that it's not drawing current, and all the energy in the battery I can use for my soldering iron. The only issue is on the NICAD, I suppose it was inevitable, that LED is on. Now the LEDs are just connected to 4 outputs on the microcontroller via resistors. If that's on, the microcontroller must be on, and in fact actually that regulator is warm. So on the NICAD something odd is going on. Maybe this was always intended to show whether there was some sort of connection disconnect issue. However, I've tried this on all the lithiums, and on all the lithiums there's no issue. It wouldn't surprise me if on the lithium batteries that third connection wasn't actually connected at all, because of course these batteries have their own temperature sensors inside. They've got MOSFETs to switch off the output if they're overloaded, over temperature, all that sort of thing. So yeah, I've got a feeling that's a legacy connector. It's not actually used on the modern batteries. I'm not going to be using NICADs to power my soldering iron. Well, maybe I will just for fun. So I don't think it's an issue. So let's get on with the project. Now actually this switch is really clever because it makes this connection between the center pin of the switch and the sort of chassis metalwork, this front metalwork here, in two different ways. The center part of the switch, this sort of common line, is actually that tiny little metal blade you can see in that slot, and when I put this plug in, it pushes it out onto the outer ring of the metalwork. So that's one way that connection, which it's this strip here, is connected onto the chassis metalwork. But also, of course, as you push this thing in, this barrel, the outer of the barrel, first connects up to this chassis, then it sort of pushes itself under that little spring-loaded lever, which is, as I say, the center of the switch, making a double connection between the outer barrel and that connection there. So yes, you get a sort of double connection, which guarantees a good connection, I suppose. It's really clever. Now this is going to be extra complicated because they've actually used these 3 points, which are a punched out tang there, if you like, and 2 little tangs or tongues there. So they're all connected together. They've actually used that as a wire link to link this part of the circuit, which goes to microchip negative, to this part of the circuit, which is a sort of general ground, which a lot of things connect to. So I've got to make 2 cuts, one across there, one across there, which is going to be really awkward because it's right next to C2, which I think is the decoupling cap for the chip. It seems to be close coupled to the chip. 2 cuts, then I've got to join them back together. Then I've got to run a separate wire. Well, I'll probably run it through this area here where there appears to be a sort of hole. That then becomes my circuitry negative, which has to go to this little switch. Where did I put the switch? Don't know. Well, it goes to this point here so that it gets connected to the battery when there's no plug inserted. And then battery negative, of course, is the actual spring-loaded terminal itself. 2 cuts needed and possibly a piece of wire. Right, so I need to start filing a circular hole in there that's going to sort of span across both halves of this so that it sits centrally in this area, which looks like it was for a label originally, but it's now going to have my socket. So that's going to be very messy. Right, I've filed a hole and I've managed to get it nice and central. It looks pretty good, but it's nowhere near big enough to take that thread. So I think what I'm going to do is put the screws back in here and ream that out, if that'll work. Yeah, problem is this reamer is going to want to push the 2 case halves apart. I've screwed them together with the 2 screws. I need something to lever that to turn the reamer. Let's see how we get on. Right, luck seems to be on my side here because the reamer just hit the tip of it, just hit the other side of the case. And that is absolutely perfect. Fantastic. Now, being a bit of a nerd, I'd quite like to attach this socket to the circuit board and the battery positive sort of spring and the battery negative spring with really thick wire. This is probably a little bit too thick, but it's all I've got. That's 18 SWG. So yeah, so that the whole thing sort of comes out as one assembly with this socket sort of attached under there and through the board and all the rest of it. So let's try that. So I'm just trying to get a hole drilled for circuit negative. Oops, it's quite hard to do. No, it's sliding because I can't get my camera in the right place. Right, I've drilled a hole in the board there and scraped an area of copper there so that I can solder my first sort of stiff wire onto circuit board negative. Circuit board negative is here, PCB negative, which goes to that pin that disconnects when you plug in a plug. Of course, PCB positive already goes to battery positive because battery positive is one of these springy bits of metal. And now, ironically, I need the soldering iron just to put this little tiny wire link I've made to bridge around the battery negative connector, because the battery negative connector is the one that I need to isolate. So I'll just tin those and try and attach that tiny bit of wire. My little bridging link around the battery negative terminal and my 2 cuts were actually successful, I think. Right, I think I've got my socket mounted roughly where it's going to go on the plastic. The board is reasonably well in position, and I've got my nice big thick piece of wire going from the correct connection. I think I did a little diagram there to circuit negative. So I just have to solder that on the top there, and that should be good. So running this at 400, so I've got enough energy in terms of heat to do this. On you go. Feed lots of solder in. And yes, that's on there. That's good. Right, let's check and double check it. Tip is definitely that one, to battery positive, definitely that one. Battery negative goes to the switch common, which is there, which is this middle pin. That's correct. And then that pin, which is this one, the sort of floating one, goes to PCB negative. Pretty sure that's good. Let's see if the soldering iron works off a battery, and we can check the voltage on the iron. Right, let's give this a try. That's come on. That's the thing where the NICAD just puts the red light on. Let's press the back button on there. 19.9 volts. That should be better. Let's try a lithium. So in goes a lithium. That doesn't seem to turn that red light on, or the regulator, so that's the better option for me. Press the back button. 20 volts. Fantastic. Should get much better performance out of this on 20 volts. And I'm not sure whether I showed this, but yeah, that's all mounted on the board with really thick bits of wire, so that when I put that into the housing, it just slots into place beautifully. So I mean, it wouldn't really even need the nut, because that's got a lot of metal behind it stopping it going anywhere, but I'll put the nut on there anyway. I might not bother with the spring washer, but yeah, that all looks pretty solid. So yeah, it was a bit of a palaver, but I think overall it was worth it, because that's now a really nice, neat little unit. And it should still work as a battery tester, but when I plug the iron in, the battery tester should shut down, and it's my iron adapter. So all back together again, looks really good. Battery tester, that all works. That's a lamp test thing. Then it shows you the level of the battery. Plug in my soldering iron. That cuts out, the iron comes on. It's got 20 volts or 19 volts. Oh, I'm happy. This is excellent. Cheerio.